All right, moving on to 1.11, verbal expressions, notes. The objective here is that when we're done with the lesson, that you should be able to translate a verbal expression into an algebraic one. All right, so I want you to take some time to see if you can create lists here for these 4 questions. All right, we want to be able to come up with words that imply these different mathematical computations. All right, so again, some words would be pretty obvious. Others you're probably going to have to think about a little bit. All right, so again, think about all the word problems that you've ever done, and some of the word or word phrases that may imply, again, these different mathematical computations. All right, so let's see how your list came out compared to what I came up with. Now, these aren't necessarily the only word or word phrases that can imply these different mathematical computations, but these are probably more of the more common ones that you may see. Okay, so again, for addition, we got add, sum, total, more than, increased by. All right, subtraction, you got subtract, difference, less than, decrease, decreased by. For multiplication, you got multiply, product, times, double, square of. And then for division, you got divide, quotient, ratio of. All right, so again, these are just some of the word phrases that you may see. And that's the bell saying that we got to move on. All right, so now we familiarize ourselves with some of these word phrases that, again, imply mathematical computation. Let's see how you can apply those in trying to write algebraic expressions from these verbal expressions. Like, for example, part A is saying 5 added to a number m. All right, so 5 added to, all right, so we know that's going to be addition. So I have my number m, and we're going to add 5 to it. All right, so let me give you some time, see what you can do with these different word phrases, and we'll check back here in a bit. All right, let's take a look at how you did. The sum of a number, x and 8. So we see the word sum, so we're definitely going to be adding here. So x plus 8. The product of 2 and y. Product, again, means multiplication. So 2.y or 2y. All right, so now be careful. Let's not use our traditional x to represent multiplication. Right? Some of you may have written like 2 times x, 2 times y. Right? So again, let's not do that for multiplication. Right? Because we have x as a variable, so we don't want to misread anything here. For part D, it says subtract 1 from a number C. All right, so take a look at what you wrote here. Again, if you wrote 1 minus C, make sure you make that correction. All right, subtraction, as we know, is not commutative, meaning the order does matter with subtraction. All right, if we kind of go back to part A and part B, right, where I wrote m plus 5 or an x plus 8, I mean, for those, because addition is commutative, I mean, we could have written those expressions where we flip-flop the order and would still work. All right, but for part D, we got to be careful that, and we have to understand that C minus 1 and 1 minus C are not the same thing. Okay, because subtraction is not commutative. If you think about subtraction, like if you took 5 minus 1 and we do 1 minus 5, switch the order, again, we would get 2 totally different answers. again, proving that subtraction is not commutative. So we want to make sure we understand, right, when we read an expression dealing with subtraction, how do we determine the order? Because it does matter. All right, so when you have a problem like D, to subtract 1 from a number C, right? The fact that we have this word from says that we are going to flip-flop the order in the way we read it into the way we write it, okay? All right, so because we see the subtract from, we're going to flip-flop the order of how we write it. So we read the 1 first and then C second. So when we write it, it's going to be C minus 1. Same thing for part E, when we see 3 less than a number Z. All right, again, if you wrote it 3 minus Z because you saw the 3 first, and then less than means subtraction, and then the Z second. All right, make sure you make the adjustment. All right, so again, how do we know? Well, for less, we see less than. That than is going to be the key that tells you that we're going to switch the order, the way we read it, to the way we write it. Okay, so 3 less than a number Z is going to be written as Z minus 3. All right, moving on to F. Twice a number H, 2H, 2 times H. 1 more than the product of 7 and X. So here's an algebraic expression that has more than one computation in it. Right, so we see more than, which means addition, and then the word product, which means multiplication. So we want to make sure we understand, right, how we're going to write this. All right, so when you think about order of operations, right, PEMDAS, whatever you use, remember that order of operations. All right, so through order of operations, we're going to do the product. So we see product of X plus 7. Or sorry, X and 7. So we're going to write that as 7X. And that we want 1 more than that product. So we're going to take 7X and we're going to add 1. Okay. So again, because addition is commutative, if you wrote 7X plus 1 or 1 plus 7X, you're still good. H, X less than 26. Okay, so again, we see the word less, so we know it's subtraction. Right, but again, because of the word than, we're going to switch the order from what we read to what we write. 26 minus X. The third power of A. Okay, so we see the word power, so that's exponents. So it's A to the third. J, 2 times the sum of X and Y. Okay, so again, with these, we're going to start with the back end, and we're going to first figure out how to write the sum of X and Y. So that's X plus Y. And then we want 2 times that. So multiplication, so it's 2 dot or parentheses X plus Y. A number D increased by 12. D plus 12 or 12 plus D also works. The square of the sum of X and Y. Again, just like the previous problems, we are going to start with the back end. Write the sum of X and Y, 5 plus X or X plus 5, either order. And then we want to square that. All right, and finally for this set, the quotient of K and 100. Quotient means division, so K divided by 100. All right, so again, let's use a fraction bar to indicate division. Let's not write this using the old-fashioned division symbol. Okay, so let's not do that. All right, moving on to example 2. The length of a rectangle is 3 less than twice the width. So we want to label a figure, use the variable W for the width. Okay, so let's go ahead and do this one together. Then you'll do number 3 on your own. So the width is W. And then now we want to write an expression for the length. All right, so again, we don't want to just write L. All right, we want to be able to write an expression for this rectangle, whatever we're trying to find, whether it be area or perimeter. We want to be able to use one variable. Okay, so we'll let the width be represented by the W. So now for the length, it says the length of a rectangle is 3 less than twice the width. All right, so again, we're keying on this expression right here for the length. So again, using our knowledge of these word phrases, right? So we definitely see 2, right, operations here. We see less than, which means subtraction, and then twice, which means multiplication, right, times 2. So like we did in the previous page, we're going to start with the back end here. So we're going to do twice the width. So that's going to be 2W. All right, 2 times the width, twice the width is 2W. And what we want from that is 3 less than. All right, so we're going to subtract 3. All right, so now that we found the expression for the length, now we can write an expression for the area of that rectangle. So the area we know is us multiplying the 2 dimensions together. All right, so the area, an expression for area for this rectangle is 2W squared minus 3W. Part B is asking us to evaluate the expression for area if the width is 8 inches. So again, we're going to take this expression for area. We're going to plug 8 in. So now what I'm starting to do here is I'm using this notation called function notation, where I am making known to the reader that I am plugging in this value of 8 into my expression. Okay, so that's all that this is, right? And I'm not taking area and I'm multiplying by 8. This is just a thing called function notation, where I'm letting the reader know what I did to the original expression. All right, I am plugging in an 8 in for W. All right, so the area with the width being 8, the area for that rectangle is 104 meters squared. All right, so let me give you some time to see if you can do example number 3 on your own. So we want to label each side of the triangle based off of what's given in the problem. Find an expression for perimeter, right? So again, we're looking for perimeter this time. And then see if you can answer part C once you're done with that. All right, so we already have one of the sides labeled X. They are telling us that we have another side that is 1 more than twice the first. So again, looking at this expression, 1 more than twice the first. So the first again was X, so we want twice that, so it's 2X. And we want 1 more than twice that first side, so we're going to add 1. So 2X plus 1 is going to represent the other side. So the third side we see is 5 less than the sum of the other 2. So here I wrote an expression where I'm adding the other 2 sides, and then I'm doing 5 less than that. Okay, so now that I have expressions for all 3 sides, that's going to allow me to find the perimeter. All right, so for part C, it's asking about all right, and finally for part C, it's asking why, and then you know why X cannot equal 1, because if you use a third side, we plug 1 in for X in that expression, we would get a side that would be a negative value, and you can't have a negative value for a side. Okay? All right, let's go and do the homework. If you have any questions, let me know.